On June 13, 2025, Israel launched a series of large-scale precision strikes targeting Iran's nuclear and military infrastructure. The operation was codenamed Rising Lion. After months of research, we've mapped out these secret Iranian nuclear sites, some hidden deep underground, others in plain sight. Each location reveals part of the bigger picture. But more importantly, we need to understand why Israel is so determined to halt Iran's nuclear enrichment, which according to Israeli intelligence, Iran's centrifuge may be just days away from producing a nuclear bomb. Not to forget the detailed process of how they are made. We'll also break down Israel's strategy and examine the targeted sites and uncover the real reasons behind this dramatic escalation, all in the video ahead. Iran has several nuclear programs, but let's take a look at some of the key underground facilities. First, we have Fordo Nuclear Program. It is an enrichment site built into a mountain, providing better protection against potential bombardment compared to the fuel enrichment plant. The second site is the Natanz Nuclear Facility. It houses several facilities, including 2 enrichment stations, the vast underground fuel enrichment plant, and the above-ground pilot fuel enrichment refinery. The third nuclear facility is Isfahan, the largest nuclear technology center located on the outskirts of the city. It includes the fuel plate fabrication plant and a uranium conversion facility capable of processing uranium into uranium hexafluoride, which is then fed into centrifuges. The fourth nuclear site is Kandab. Iran has a partially built heavy water research reactor here, originally called Arak, but now known as Kandab. Finally, we have Bushehr, Iran's only operational nuclear power plant located on the Gulf Coast. It uses Russian fuel, which is then returned to Russia once spent, thereby reducing the proliferation risk. Let's take a look at a simplified version of how Iran's nuclear extraction and enrichment process works. This is the uranium ore, and it is extracted using a drill that pulls the reamer up through the pilot hole, widening it. The broken ore then falls into what is known as an extraction chamber. Next, a bulldozer, operated remotely to keep the operator at a safe distance from falling rock hazards, picks up the uranium rock. Fast forward, the uranium is then condensed, ground, and placed into a centrifuge for further enrichment. Everyone is talking about centrifuge enrichment, but let's explore how it actually works. In this visualization, the green dots represent uranium-238 atoms, while the blue dots represent the concentration of uranium-235 atoms. This first batch is natural uranium, which contains only 0.7% of uranium-235. Here, in this image, we have 5% low-enriched uranium, which is used for commercial nuclear power plants. Finally, we have weapons-grade uranium, which contains 90% uranium-235. As you can see, almost all the uranium-238 has been removed, and it is replaced by uranium-235 representing the color blue. Let's show how this is extracted through super simplified animation. The centrifuge consists of a high-grade tube with a spinning motor at the bottom and a feeding tube at the top. Uranium is fed into the centrifuge as a gas called uranium hexafluoride. As the motor spins at high speed, the heavier uranium-238 is separated from the lighter uranium-235 using centrifugal force. The uranium-235 floats to the top and is collected at this section of the centrifuge, while the heavier uranium-238 in the color green falls to the bottom of the centrifuge and the enrichment process is complete. Let's take a look at how Israel uses its Air Force to strike nuclear targets. At 3:30 in the morning, Israel launched around 200 fighter jets, deployed over 330 munitions to strike dozens of nuclear and military targets, Iran's primary enrichment site, and missile production complexes. Although these routes may seem straightforward, they involve complex planning, including calculations for air refueling and coordinating attack aircraft to pass through Jordan, Syria, and Iraq. They also neutralize potential air defense threats in Syria and Iraq to ensure a safe return in case they were targeted. Israel's strategy was to attack Iran in 3 waves. The first wave targeted surface air-to-air sites, radar installations, and Iran's air defense headquarters in Tehran, Elam, and Khuzestan. The second wave focused on destroying ballistic missiles, and finally, the third wave targeted military manufacturing industries. To avoid Iranian air defenses, they used the ROX missiles, which allowed them to strike from positions closer to enemy targets without requiring jets to penetrate deep into Iranian territory. Surprisingly, the Iranian Bavar 373 air defense system performed better than expected. We'll also look into how this air defense missile works and the strength of the Iranian Air Force, all in the video ahead. Let's us first look at Israel fighter jets used in the operations. The tip of the spears are the 5th-generation F-35 fighter jets, S-16 air defense jets, and F-15 ground attack jets, which covered approximately 1,600 kilometers, translating to around 1,000 miles. While the weapons of choice were the Blue Arrow long-range supersonic missile and the Rock's next-generation extended standoff air-to-surface missile. To cover such distances, air refueling tankers were used between flights. This measure was taken in case they needed to engage in a dogfight with Iranian fighter jets and also while returning from their mission. ROX is Israel's next-generation extended standoff air-to-surface ballistics missile. Israel's strike also took out General Hossein Salami, one of the country's most powerful and influential military commanders. It also allows the weapon to hit targets that have moved from their original positions. But in area of high-threat situation, these bombs typically use a GPS-enabled inertial guidance system to guide them to the general target area, before switching to an imaging infrared seeker for the terminal stage of flight, destroying the targets with deep penetration or blast fragmentation as required. Surprisingly, the Bavar 373 and S-300 missiles successfully intercepted Israeli drones and some missiles. Let's take a quick look at the Bavar 373. This system uses Sayed-4 missiles, which are housed in 2 rectangular launch canisters. It features a phased array radar system for tracking both aerodynamic targets and ballistic missiles over medium to long ranges. One of the radars used in the Bavar 373 is the Mirai-4, a phased array radar with a range of 450 kilometers, which Iran claims this system can simultaneously track up to 200 targets. The Israeli attack can be divided into 3 distinct phases: first, second, and third wave, each targeting critical components of Iran's military infrastructure. The first wave focuses on disabling Iran's air defense systems. Tehran, Elam, and Qubzes, that are some of the region-verified attacks also confirmed by Iran that were hit or partially damaged. Key targets include surface-to-air missile or SAM sites and radar installations, crucial for early detection and defense against aerial assaults. Iran's air defense headquarters confirmed the attacks happened, which aimed to cripple the nation's ability to track and respond to future incoming threats. While the second wave targets Iran's missile capabilities, specifically focusing on neutralizing both ballistic and hypersonic missile systems. At least 3 missile bases were attacked in a second round or second wave of Israeli strike. IDF drones also targeted the secretive Parchin military base in the outskirts of Tehran, and finally 1 drone made it through the Iranian air defense and hit the base while others were shot down. These strikes are designed to prevent Iran from launching retaliatory missile strikes. The third and final wave focuses on destroying key military barracks and manufacturing facilities essential to Iran's missile production and military logistics. Targets include the Qadiri Barracks and Hassan Khan Castle, a missile manufacturing and preparation center. The Sepah Air Force Logistics Center and Imam Ali Barracks are allegedly included in this phase to disrupt logistical support and command structures. Israel were trying to target these missiles bases like the Fatah-1 and Fatah-2 missiles. It was used for the first time and is one of Iran's advanced missile systems. What sets it apart from other ballistic missiles is its ability to accelerate outside the Earth's atmosphere, while its aerodynamic control surfaces enable steering to evade the famous Arrow missiles defense system made by Israel. Israel was also looking to strike these ground-launched ballistic missiles that targeted the IDF bases. Israel also wants to dismantle. The Shahab-3 is the foundation for all of Iran's medium-range ballistic missiles and uses liquid propellant. From outer space, military satellites will pick up targets like this heavily fortified bunker. The Israeli are also believed to have tested these newly built LoRa missiles. Coordinates data have to brief and assign to a designated attack aircraft to strike with precision without entering into enemy airspace. This is LoRa, a ballistic missile precision engineered for accuracy capable of engaging strategic assets deep within hostile territory, from jet fighters to a heavy mission aircraft like this one. According to the company, Air LoRa can travel across vast distances, delivering fast response impact without engaging their defense systems or encroaching on enemy airspace. It does this by striking from above at a 90-degree angle with supersonic speed. This air ballistic missile can penetrate air defense shield carrying a warhead that can be guided by GPS and inertial navigation system that is immune to jamming. It is also equipped with a huge warhead that ensures critical targets are neutralized with a single strike. You might be asking, where are the Iranian fighter jets and how do they compare against Israel in this attack? Let's break this down into several parts. To fight against the F-16 and F-35 jets, the Iranian have the tip of the spear. It consists of American-made aircraft, around 64 numbers of F-4 Phantoms that Iran purchased during the Shah's regime. The F-4 Phantom is Iran's primary attack aircraft and is considered the backbone of the Iranian Air Force. In addition, Iran possesses around 40 numbers of F-14 Tomcats, also American-made, which still have the capability to pose a threat to the F-35. Iran also acquired approximately 30 MiG-29 multirole fighter jets from Russia, interestingly designed to counter the F-16. The second part of the air defense is the $800 million S-300 air defense system, which is capable of intercepting targets at a range of 120 kilometers that translates to about 75 miles. When launched on a ballistic trajectory, it can reach distances of up to 400 kilometers, that is around 250 miles.